RHEL 5.0 IP tables. In Linux has two main security features available: IP tables and SC Linux. SC Linux, it means the security enhanced Linux. It's provide a policy based security, and if you want to block and allow and deny some like protocol traffics and other different type of traffics, for that we are use IP tables. You want to block unauthorized access in our network, for that we are use IP tables. Today we learn IP tables. In network, security is a primary consideration in any decision and to host a website, as the threats are becoming from more widespread and persistent every day. That better integrations with the Linux kernel with the capability of loading the IP table specific kernel modules and designed for improved speed and reliability. It's a stateful packet infection. It means that the firewall keep a track of each connection and passing through it, and in certain case will view the content of data flow in an attempt to anticipate the next action of certain protocol. This is an important feature in the support of active FTP and DNS as well as many other network services. Second is the filtering the packet based on a MAC address. The value of flag in the TCP header. This is helpful in preventing the attack using the malform packet, and it restricting the access from locally attached server to other network in split of their IP address. First of all, we understand how to start the IP table. For that we run following command. In our Linux, if you want to start the IP table, run the service IP table start command. If you want to stop, for that run the service IP table stop command, and restart the IP table service, then we want to run service IP table restart command. In Linux by default IP table RPM is installed. The next is how to determine the status of the IP table. So you can determine whether the IP table is running or not via the service IP table status command. So here you see the output, firewall is stop. It means the IP table service is stop. It's not working. So here you see the status of firewall. Next is the packet processing in IP tables. All the packet inspected by the IP table pass through a sequence of built-in tables. It means queue for processing, and each of these queue is dedicated to a particular type of packet activities, and it's controlled by associate the packet transformations and filtering chain. And there are the basically three main tables: mangle tables, packet filtering table, and net tables. And these tables are running is available in IP tables. There are the three main concepts to learn. First is the mangle tables. So here the first is the mangle table, which is responsible for alterations of quality of service bit in a TCP header, and this is handled by in a home, small office environment. Second is table is a filter queue, which is responsible for packet filtering, and it has three built-in chain in which you can place your firewall policy rules. Here in packet filtering table has contained three main rules. First is a forward chain rule, second is the input chain, and third is the output chain. Forward chain, it means the filtering the packet to server protected by the firewall. Input chain, it means the filtering the packet destined for the firewall, and in output chain filtering the packet originated from the firewall. So here there are three main rules in packet filtering table. Next and third table is the net table. Okay, the net table is which is responsible for network address translation, and it has a two built-in chain. These are the pre-routing chain. It means the net packets when the destination's address of the packet need to be changed. And second is a post-routing chain. It means the net packet when the source address of the packet need to be changed. So there are the two main rules working in a net table. And next is -I and then interface name match the input interface on which the packet enter. -O interface match the output interface on which the packet is sent. There are the different rules options we are using rules. So here in these rules we are use -A for append options, -S for source address, -I for interface, -D for destination, -P for protocols, and -J for jump. You see in these rules here we are using different options to configure rules. And next, each firewall rules inspect each IP packet and then try to identify it as a target of some sort of operation. Once a target is identified, the packet need to jump over to it for further processing. There are the three target policy: accept, drop, and reject. Accept, it means the IP table stop further processing and the packet is handled over to end application of operating system for processing. For that we are use accept. But they have also number of command line options. Here in this policy we use accept. Next is a drop. It means the IP table stop the further processing and the packet is blocked. And next and last is the reject. It means the works like the drop target, but will also return an error message to a host and sending the packet that the packet was blocked. So here drop and reject are same, but drop cannot get back a error message, but reject can sending a error message, can return the error message. Here we are used in this rules is accept. And next one is to the processing for a packet written by the firewall. There are the three processing: forward, input, and output. Here in forward it means the filter the packet to server accessible by under NIC on a firewall. Next is the input. It means the filter the packet destined to the firewall. And last is the output. It means the filter the packet originated from the firewall. So here there are the three processing rules we are used in IP table to configure IP table rules. So here in these rules we are use a input. It means the filter packet destined to the firewall. And next is -I and then interface name match the input interface on which the packet enter. -O interface match the output interface on which the packet is sent. There are the different rules options we are using rules. So here in these rules we are use -A for append options, -S for source address, -I for interface, -D for destination, -P for protocols, and -J for jump. You see in these rules here we are using different options to configure rules. And next, each firewall rules inspect each IP packet and then try to identify it as a target of some sort of operations. Once a target is identified, the packet need to jump over to it for further processing. There are the three target policy: accept, drop, and reject. Accept, it means the IP table stop further processing and the packet is handled over to end the application of operating system for processing. For that we are use accept. Here in this policy we use accept. Next is a drop. It means the IP table stop the further processing and the packet is blocked. And next and last is reject. It means the works like the drop target, but will also return an error message to a host and sending the packet that the packet was blocked. So here drop and reject are same, but drop cannot get back a error message, but reject can sending a error message, can return the error message. Here we are used in this rules is accept. And next one is to the processing for a packet written by the firewall. There are the three processing: forward, input, and output. Here in forward it means the filter the packet to server accessible by under NIC on a firewall. Next is the input. It means the filter the packet